Welcome to solverfy.
So in this question, we're given two drums, B and C, and we have the radius of B to be 20 millimeters and a moment of 0.3 Newton meters. And we have C with a force of P on the right side and B with a force of T downwards. We were given the static coefficient of friction to be 0.4 and the kinetic coefficient to be 0.3. And we're asked to calculate the value of P when C is stationary. So let's draw our two free body diagrams of these two drums. So for B, we have tension TA on the left side. We'll call it a tension TB on the right side. We have an angle of pi, or half a turn. We have the radius of 20 millimeters, or 0.02 meters. The moment of 0.3 Newton meters. And since it's an impending slip problem, we use the static coefficient of friction of 0.4 for disk B. Now for disk C, we have P on one side, TB on the other side, an angle of 90 degrees or pi over 2 radians in the belt. And we're going to use the kinetic coefficient of friction because C is stationary but the belt moves. So that's 0.3. And we have impending slip in the direction of P for drum C. So let's solve our impending slip equations for this problem to get our value of P. So first, we take the difference in the tension, TA minus TB, times the radius to be equal to the moment for disk B. So TA minus TB is equal to 15 newtons. That's our first equation. And then our second equation is the impending slip equation. So TA over TB is equals to E to the angle times the static coefficient of friction. So TA is equals to 3.513 TB. And that's our second equation. So we'll substitute that into our first equation to find our values for TA and TB. So when we substitute that, we basically get 2.513 TB is equal to 15 newtons. So TB is equal to 5.97 newtons. And TA is equals to 15 minus 5.97, which is 9.03 newtons. We substitute that back into our free body diagram for C, and we use that to calculate P. So since P is the direction of impending slip, we have P over TB, which is 5.97, is equals to E to the power of the angle, which is pi over 2, times the kinetic coefficient of friction in this case, because the drum doesn't move. And so we have P to be equal to 9.56 newtons. And that's our answer to this question.